Students, today we will be solving problem based on intersection of events and union of events. Both the concept has been explained in my previous video. Link is given in the description below. Before solving the next problem, let us understand what cards contain in a deck of cards. When I say deck, I mean pack of cards. Every pack contains 52 cards, right? Okay, let us talk something about cards first. Okay, so in a pack of card there are 4 types of cards, right? Okay, one is heart shaped. Just a second. If you see a pack of card, there are 4 shapes, right? Heart, diamond, spade, oh, just a second. Spade and club, right? These are the 4 signs. So spade and club are black in color, heart and diamond are red in color, right? And every card has every sign has 13 cards, right? So 13 cards are ace, ace 2 3 4 5 6 7 8 9 10, and then jack, queen, king, right? So jack, queen, king are face cards, and remaining 10 are number cards, are called as number cards. So ace 1 2, no, not 1, sorry, ace is only 1. So ace 2 3 4 5 6 7 8 9 10, right? And then 3 face cards, which is jack, queen and king. So these are the cards, these are the numbers which are there in the cards, correct? So every sign has 13 cards. So every sign has 13 cards, which makes 26 red cards and 26 black card, and total it makes 52 cards, right? Okay, so I believe that everybody is familiar with playing cards. Okay, so let us start with the next question. Okay, before starting the next question, we'll just revise what is union and what is intersection. Okay, so when I say intersection, when I say intersection, suppose A intersection B. What is the meaning of intersection? Intersection means the components which are common, right? So if I say my event A is black cards, okay, in a pack of card, select black cards. When I select one card, what is the probability that it is a black card? So my sample space would be 52 because there are 52 cards in a deck, right? My event A is black card. So total number of black card, how many black cards are there? Total 26, right? This is my event A, 26 black card. My event B is, suppose to select ace. Okay. To select ace is my event B. How many ace is there? In one pack of card, there are 4 ace. One ace of spade, ace of club, ace of heart, and ace of diamond. Right? So there would be 4 ace. Right? Out of this, when I am saying 4 ace, 2 ace are black in color and 2 ace are red in color. Right? So those 2 ace is common because they are black. Right? My event A was black cards. And my event B was ace cards. So ace cards are 2 ace cards are black in color and 2 ace cards are red in color, right? So which is common here between A and B? Ace of spade and ace of club is common, right? So A intersection B is 2 by 52. Right? These two components would be the point of intersection. Right? Okay. And what is union? Union means A and B, both the event together, but none of the points are getting repeated. So ace means, when I say ace, I mean 4 cards. Right? And when I say black cards, that means 26 black cards. And because there are 2 cards which are getting repeated, which is in this also and this also. There are 2 cards which is in this ace cards and as well as in black cards. Correct? So those 2 cards are getting repeated. So I will subtract that part. So what I am doing? I am subtracting the common card because I don't want anything to get repeated. Right? So now the total number of cards for A union B would be 4 plus 26 minus 2, which is 28 cards. Right? So probability would be 28 divided by 52 because sample space is 52. Okay. A proper explanation is given. I have explained this in the previous video. This is just a revision. So I would recommend you to check my previous video where union and intersection is explained. Okay. Now let us start solving the next problem. Question number 10. Let's see the question. This is the question number 10. A card is drawn from the pack of 52 cards. Find the probability of getting spade or ace or red cards. Okay. So you have to find the probability of getting spade or ace or red cards. Okay. When or is given in the question, okay, it means you have to find out union. They have asked you to find a union of, if I name the event, I will name event A. I will name spade as event A, ace as event B, and red card as event C. Okay, so they are asking A union B union C, the probability of A union B union C. Find the probability of getting spade or ace or red card. Okay, let us start solving. What is the sample space? Sample space is going to be 52. Yes, because there are 52 cards in a pack of card. There are 52 cards and it's already given in the question. A card is drawn from the pack of 52 cards. So you know it is 52. So your n of s is 52. I will name the events. Okay. Event A. Card is spade. Spade means this sign. Okay. Event B. Card is ace. Right? Ace means ekka. Event C. Card is red. Okay. So I have named the events. Okay. You know how many in a pack of 52 cards, how many cards are spade? So 13. Right? How many cards are ace? Ekka. There are 4 aces. Right? And how many card is red? So diamond and hearts. They are red. So total 26 cards are red. Okay. So I can say from here I can say that n of A is 13 because there are 13 spade cards, right? N of B is 4 because in a pack of cards there are 4 ace cards, and n of C is 26 because there are 26 red cards, right? If I am asked to calculate the probability, it is very easy. P of A would be 13 divided by 52, P of B would be 4 divided by 52, and P of C will be 26 divided by 52. Correct? Okay. But what they have asked? They have asked find the probability of getting space or ace or red cards. That means the question asked is what is P of A union B union C? This is the question. In the yesterday's video, I have explained the formula of A union B union C, right? So let us write the formula. I hope everybody remember. Probability of A plus probability of B plus probability of C, and then you have to subtract all the common points. So you will be subtracting all intersections. So probability of, you will subtract probability of A intersection B minus probability of A intersection C minus probability of C intersection B or B intersection C. It is one and the same thing, right? And then you will add back the middle part, which is probability of A intersection B intersection C, right? Do you all remember yesterday? I'll just make a diagram for you. See, yesterday I made this diagram like this, something like this, right? And then you have to add back the middle portion, right? Okay, so let us find the probability of every component which is there on the right hand side. Okay, so first one is, let us find probability of A. What is probability of A? That is probability of getting a spade, right? Okay, so P of A will be N of A divided by sample space N of S. Correct? So P of A is 13 by 52. I will not simplify it now. Okay, I want the denominator to be the same. Okay, then P of B will be N of B divided by N of S. The next one. So P of N of B is 4. So 4 divided by 52. Right? Similarly, P of C is N of C divided by N of S, which is 26 divided by 52. Right? Then I want P of A union B. Okay. What is A? Not union, sorry. P of A intersection B. Right? That I am supposed to subtract. So you have to find out P of A intersection B. Right? Before finding P of A intersection B, let us see what is N of P intersection B. So N of A intersection B is where A and the points, the components which is common between event A and event B. So components which are common between event A and event B. Let us see. What is event A? Event A is excuse me. Event A is card is a spade and event B is card is ace. So spade, there are 13 cards, right? Which all are the cards? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen and King. These are the cards, right? Which are the components of event A, right? And event B is cards which is ace. So ace cards are ace of spade, ace of club, ace of heart and ace of diamond, right? So which is common? Ace of spade is common between A and B. That means there is only one card which is common, right? So that means A intersection B is 1. Because there is only one card which is common between event A and event B, right? Ace of spade. Ace of spade is common. Ace of spade is common. So your N of A intersection B is 1 card. Correct? And let us see A intersection C. Okay. A intersection C. What is A? A is card is a spade. And A intersection C, card is red in color. Okay, spade is black in color. There is no common point at all, right? The one which is red in color cannot be spade. The one which is spade, it cannot be red in color. So here the probability is 0. There is 0 cards which is red as well as spade, because spade is black in color, right? So here there are 0 cards which is red as well as spade. If the card is spade, it is black. It cannot be red. So you know that there is no card which is black, spade as well as red. So your A intersection C will be 0. Okay. Next one is C intersection B or B intersection C. B intersection C, common between B and C. Okay. What is B? B means four ace cards, right? Four ace cards are ace of club, ace of spade, ace of heart, ace of diamond, right? And 26 red card. C is 26 red cards. So there are 26 red cards. Red cards means diamond and heart, right? And they both have ace cards. Ace of diamond, ace of cards. So there are two cards which are common, right? Ace of heart and ace of diamond. So between B and C there are two cards which are common, right? Now we have find out intersection. We have found out A intersection B, A intersection C, and B intersection C. Now we need a card which is, let's find out which belongs to A, B as well as C. So is there any card which belongs to event A as well as B and as well as C? Let us see that. Okay. So a card which belongs to all the three. Okay. A card which is spade also, which is ace also, and which is red also. Is that possible? No, it is not possible. A card which is spade, it cannot be red. Right? So if any one of the above, if any one of this is 0, then this is also 0. Okay, because that means there is no card which is A as well as C, which is spade as well as red, right? So there is no common card which is spade, which is ace as well as red. So there is no card which is common to all the three event, right? Now let us find probability. So probability of A intersection B is equal to n of A intersection B divided by sample space, which is 1 by 52. P of A intersection C would be n of A intersection C divided by n of S, which is 0 only. P of B intersection C is equal to n of B intersection C, which is 2 by 52. And P of A intersection B intersection C would be n of A intersection B intersection C. This is also 0. Now we know all the components of, we have calculated P of A, we have calculated P of A, P of B, P of C, P of A intersection B, P of A intersection C, P of C intersection B, and P of A intersection B intersection C. We have calculated all the components of right hand side. So you can find out, now you can find out P of A union B union C. So formula I have already written. You no need to write the same formula again and again. You can just start writing. P of A union B union C is equal to, what was P of A? P of A is 13 by 52. 13 by 52 plus 4 by 52 plus 26 by 52 minus 1 by 52 minus 0 minus 2 by 52 plus 0. Right? I did not simplify so that my denominator is common. Okay. So 13 plus 4 plus 26 minus 1 and minus 2. So 13 plus 4 plus 26 minus 1 minus 2. Divide by 52. Please calculate. How much it comes to? I think it comes to 40 by 52. Yes? 23, 24, 30, yeah. 40 by 52. So now you can simplify. So the final answer is 10 by 13. Yeah. Let us come to the next question, which is problem number 11. From a pack of 52 playing cards, all cards bearing number which are multiple of 3 are removed. Okay. After that, a card is drawn at random. What is the probability that the card drawn is face card, red card, even number, red card? Okay. So there is 3 sub questions. Okay. First, what they are saying? They are saying from the pack of 52 playing cards, all the cards bearing the number which are multiple of 3 are removed. Fine. So there are in playing card there are 4 signs, which is hearts, diamond, spade and club. Right? Everybody has 13 cards each, which makes it 52. Correct? Ace 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen and King. Right? So every sign has 13 cards. Fine. Now what they are saying, out of these 52 cards, all cards bearing the number which are multiple of 3 are removed. Okay. So numbers which are multiple of 3 are, one is 3, 6 and 9. Correct. The number cards are from 1 to 10 in a playing card, right? You have ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the number cards in a playing cards. In a pack of playing cards, right? So multiple of 3 are removed. Cards bearing the number which are multiple of 3. Multiple of 3 are 3, 6 and 9. Right? So 3 cards you are removing from each sign. So minus 3, minus 3, minus 3, minus 3. You are removing. So only 10 is left. Correct? Which makes the sample space 40. Okay. I don't want to write like this. So 3 cards of all sign is being removed. So 3 cards from 4 signs is being removed. So 3 into 4 is 12. Right? So you are removing 12 cards and then what is remaining is 40. So this is your N of S. From the 40 cards, after the After that, a card is drawn at random. So from 40 cards, you are selecting a card. So your n of s would be 40. What is the probability that card drawn is a face card? Okay. Face card means Jack, Queen and King. Right. So Jack, Queen and King means 3. There are 3 face cards for every sign. So 3 into 4. You have not removed those cards. You have removed cards which are multiple of 3. So in this 40 cards, there are Jack, King and Queen. So 3 face cards of every sign. There are 4 signs. So 3 into 4. So they are 12 cards. That means the answer for the first part of the question would be 12 by 40. So probability is going to be 12 by 40. Right. So second part is red cards. Okay. How many red cards are remaining after removing the... You have removed few cards, right? So after removing those cards, how many cards are left? -3, -3. You have removed those cards. Only 10 cards are left. So red cards, only 20 cards are left. Right? So the probability that the card drawn is a red card. So the answer would be 20 divided by 40. This is going to be the answer. Right? And the last part, even number red card. Okay. Even number red card. Okay. What all are the cards which are remaining? First, let's see that. Ace is not an even number though. 2, 3 is not there. 4, 5, 6 you have already removed. So 7, 8, 9 is removed and 10. These are the number cards which are left. Right? Okay. So even number red cards. Even number red cards are 2, 4, 8 and 10. Right? Red cards, there are two sets. Right? One is diamond and one is heart. So that means 4 plus 4. There are 8 cards which are remaining. So the answer for that would be 8 divided by 40. Correct? Okay. So I hope everybody has understood the question. Everybody has understood the solution as well as the question. So let us start writing the solution. Okay. Just write down. There's no need to write all these things, okay? Don't write this. Write down. There are number cards up to 10. Number of multiples of 3 is equal to 3, 6, 9, which is 3 cards. Total number of set in the pack is equal to 4. There are 4 sets, right? Diamond, hearts, spade, club. Total number of cards removed from the pack is equal to 4 into 3, which is 12. Sample space is equal to 52 minus 12, which is 40. So n of s is equal to 40. Okay. Now the first part. I will name it as event A. Event A is equal to number of face card so n of A is equal to 3 into 4 just a second. There are 3 face card and 4 sets, 4 signs, right? Diamond, hearts, spade and club. So 3 into 4, that is 12 cards. 12 cards. So P of A is equal to n of A divided by n of S, which is 12 by 40, correct? You can simplify it, 3 by 10. Okay, now event B. Event B is number of red cards, right? Event B was number of red cards only, no? Let's check. Yeah, red cards. Event B is number of red cards. So total number of red card is 26. Total number of red cards is 13 plus 13, which is heart and diamond, 26 cards. But we are removing 3 cards, right? 3 into 2. So number of cards removed, number of cards already removed is equal to 6, correct? Okay, therefore n of B is equal to 26 minus 6, which is 20. So P of B will be 20 upon 40, because sample space is 40. Write the formula, okay? Every time write the formula. I'll just write n of B divided by n of s, which is equal to 20 by 40, which is equal to 1 by 2. Third part, which is event C what is event C? Even number red card. Even number red cards. Number of red cards available after removing multiple of 3 are 2, 4, 8 and 10. 6 we have removed, correct? So there are 4 cards in for every sign. Okay. There are 2 sets of red cards. So total number of red cards which are bearing even numbers are 4 into 2, which is 8. So n of c is equal to 8. P of c is equal to n of c upon n of s. So 8 by 40, which is 1 by 5. Correct? So I believe everybody have understood the sum. If any of my student is not able to understand, can WhatsApp me and ask me to explain again. Okay? Now let us see the next problem, which is question number 12. Okay. One card is drawn from a pack of well shuffled 52 cards. What is the probability that the card will be 1. A red or a king, 2. A king or a spade? Fine. Very good question. I am sure by now you will be able to solve by yourself. Those who are able to solve, please start solving. Okay. So one card is drawn from a pack of well shuffled 52 cards. What is a probability that the card will be a king or a red or a king or a spade? Whenever there is or, It means you have to find out union. Okay. Oops. Okay. So sample space is 52. Correct? Sample space is 52. It is already given in the question. Okay. So event A, I will name, let's do the first part. I will name card drawn is a red card as event A, and card drawn is a king as event B. Okay. And card drawn as a spade, I will name it as event C. Okay. Fine. So my first part is card event A. Okay. Have you understood what has been asked? Oh, that should be the first question. Wait. What is asked? A probability that the card will be a king or a red card or a king. So if I am naming the card is red as A and card is a king as B, then probability of A union B is asked in the first question, and in second part of the question probability of B union C is asked. Correct? A card can be a red card or a king. Okay, and card can be a king or a spade. Fine. Okay, let us name the event for the first part. Event A is equal to card drawn is a red card. Is a red card. So how many red cards are there in a pack of cards? 13 diamond and 13 hearts. Correct? So that means total 26 cards. So P of A, and I hope you all remember the formula. P of A union B. What is the formula? P of A plus P of B minus P of A intersection B is the formula. Right? To find out P of A union B, the formula is P of A plus P of B minus P of A intersection B. Correct? And formula for P of B union C would be P of B plus P of C minus P of B intersection C. Right? This has been explained in the previous video. Okay. So event A, so P of A would be 26 by 52. I will not simplify this. Okay. I want the denominator to be same. Okay. Event B. Event B is equal to card drawn is king. Card drawn is king. That means n of B is equal to, how many cards are there? How many king are there in one pack of card? 4, right? King of hearts, king of diamond, king of flower, king of club and king of spade, right? So your n of B is 4. So P of B would be 4 by 52. Correct? Let us find out n of A intersection B. That means a card which is A as well as B. The card which is red as well as king. So that means common card. The card drawn is a red card as well as king. There are two red cards. There are two sets of red cards, which is diamond and heart. Both have king. So there are two cards. Correct? So P of A intersection B would be 2 divided by 52. So P of A, the final answer, P of A union B is equal to 26 by 52 plus P of B, which is 4 by 52 minus 2 by 52, which is 28 by 52. So when you simplify it, it comes to 7 by 13. Correct? Yeah. Now, second part. I have defined card drawn is a king as B, right? So I am writing it again. Okay. Event B is equal to card drawn is a king. Okay. And event C, card drawn is a spade. Card drawn is a king. So my n of B is 4. P of B is 4 by 52. Event C, card drawn is a, what was C? What's the question? King or a spade? Okay. Is a spade. So my N of B will be, there are 13 spade cards. So P of B will be 13 by 52. Correct? Now intersection. So N of, oh sorry, just a second, I have made a mistake. This is not B, this is C. Now my intersection, which is N of B intersection C, that means common card, which is B as well as C, which is spade as well as king. There is only one card, right? That is king of spade. King of spade. This is the one card. So which is one card. So my P of B intersection C would be N of B intersection C, and sample space N of S. One by 52. Correct? So my final answer, that is P of B union C is equal to, because I have written formula because I have already written the formula, I am not writing the formula again. I will directly write the answer. So my P of B is 4 by 52. 4 by 52 plus 13 by 52 minus 1 by 52. Okay. So 13 plus 4 minus 1 is 16 by 52. You can simplify it. 4 by 13. Let us start the next question. A box contains 20 balls bearing numbers 1, 2, 3, 4 till 20 respectively. What is the probability that the ball drawn is a even number, prime number, multiple of 4, number less than 4, between 7 to 11, greater than 17? Okay. So first let us understand what is the question. There are 20 balls. Just a second. There are 20 balls. I'll just make 20 balls first. And each ball bears numbers, right? So this is ball 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Okay. So there are 20 balls and you have to select from these 20 balls. That means your sample space is 20, right? So N of S is going to be 20. Correct? Okay. Which is your first event. So your N of A which is the first event is even number. So it is an even number. Okay, so let us select all the even numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there are 10 balls which contains even number, right? So your n of a will be 10. Correct? So your P of A will be 10 by 20, which is 1 by 2. Correct? Okay. So this is the first part. Second part, it is a prime number. Okay. So n of B. Let us see all the prime number. Let us select all the prime number. Prime numbers are numbers which are not divisible by any other number, right? So 1 is a prime number, 2 is a prime number, 3 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 is not a prime number, 7 is a prime number, 8, 9, 10 is not a prime number, 11 is a prime number, right? 12 is not a prime number, 13 is a prime number, then 14, 15, 16 are divisible, 17 is a prime number, 18 is divisible, so and 19. So these are the prime numbers. So 1, 2, 3, 5, 7, 11, 13, 17, 19. Correct? So these are the prime numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 prime numbers here. So your n of b is 9. So your P of B will be 9 by 20. Correct? Now third part, multiple of 4. Okay. Let us see n of C, which is multiple of 4. Okay, which are the numbers which are multiple of 4? 4, 8, 12, 16 and 20. These are the numbers which are multiple of 4. Right? So your n of C will be 5 because there are 5 balls which are multiple of 4. Okay. Next, number less than 4. So number less than 4 are 1, 2 and 3. Correct? 4 is equal to 4. It is not less than 4. So number less than 4 would be 1, 2 and 3. So your n of D will be 3. Okay. Next, between 7 to 11. So numbers which are between 7 and 11. Between 7 and 11, that means you will not include 7 and 11. Okay. So I'll mark it as red. I'll mark it in red color. Okay. Numbers between 7 to 11. So I will not consider 7 and 11. Okay. So numbers between 7 and 11 is 8, 9 and 10. So your n of E will be 3. So your probability would be 3 by 20. Okay. Next one is greater than 17. Greater than 17. I'll take some random color. Okay. So greater than 17, numbers which are greater than 17 means after 17. So which is 8, 9 and 20. So your answer would be, your n of F will be 3, right? So you can calculate the probability. P of A would be 10 by 20, P of B 9 by 20, P of C 5 by 20, P of D 3 by 20, P of E 3 by 20, P of F also 3 by 20, right? Okay, let's write down the answer. I believe everybody has understood. Okay. Please write down. Sample space is equal to 20. N of S is equal to 20. There are 20 balls. Sample space is 20. So my event A is equal to, the ball is bearing an even number. So the even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So N of A is equal to 10. P of A is equal to N of A by N of S, which is 10 by 20. Therefore, your final answer is 1 by 2. Second part. B. B is the ball is bearing a prime number, correct? So the prime numbers are 1, 2, 3, 5, 7, 11, 13, 17, 19. Right? So my N of B will be, how many balls are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 balls. So N of B will be 9 by 20. Okay. Third part, my event, I will name it as event C. So event C is, the ball drawn is a multiple of 4. So numbers which are multiple of 4. 4, 8, 12, 16 and 20, right? So my N of C will be 5. P of C will be N of C upon N of S, which is 5 by 20, which is equal to 1 by 4. Now, fourth part. D. What is D? Number less than 4. Okay. Number less than 4 is 1, 2 and 3. 1, 2 and 3. So N of D is equal to 3. P of D will be 3 by 20. Correct? Fifth part, E, what is fifth part? Between 7 to 11. Okay. 7 to 11 means 8, 9 and 10. You will not include 7 and 11. I am repeating again. You will not include 7 and 11. Okay. So N of E would be 3. So P of E is N of E upon N of S, which is 3 by 20. Now sixth part, greater than 17. So my F is 18, 19 and 20. So P of F would be 3. So my P of F P of F will be 3 by 20. Correct? This was a very simple sum. I am sure you might have done it before me. Okay, let's solve the next question, which is question number 14. Okay. So question number 14. A bag contains 7 black, 8 white and 10 red balls. A ball is drawn at random. What is the probability that the ball drawn is black? Second, not white. Third, either black or red. Neither black nor red. Okay, this is very simple. So there are how many balls? 7 black balls, 8 white balls and 10 red balls. Correct? So 7 plus 8 plus 10 will be a sample space. So 7 plus 8 plus 10 is 16, 17, 25. Correct? So your event A is that the ball is black in color. So there are 7 black balls. Correct? So your N of A is 7. Right? So your P of A will be 7 by 25. Right? Not white. Not white means it is either red and or black. So red balls. There are 10 red balls and 7 black balls. So your N of B will be 7 black balls plus 10 red balls, which is 17. Right? So your P of B will be 17 by 25. Now third part, either black or red. Correct? So either black or red. Fine. So it is black or red. Fine. So that means your N of C would be black or red, means 7 black and 10 red. So here again it would be 17, 7 plus 10, black or red. So it is either black or red. So black are 7 balls, and red means 10 balls. So 7 plus 10, 17 balls. So again N of C is 17. Probability will be 17 by 25, same as above. Next one, neither black nor red. So it is not black and it is not red. So if it is not black and not red, that means it is white. Correct? If it is not black and if it is not red, that means it is white. So that means your N of D will be 8, because there are 8 balls. So your P of D will be 8 by 25. Correct? Now let's write the solution. Sample space. Is equal to 7 plus 8 plus 10 balls, which is 25. Sample space is 25. N of S is 25. First part, event A, black, that means N of A wait, I will write like this. Event A, that the ball drawn is black. So black ball is drawn. Probability that black ball is drawn. So there are 7 black balls, right? 7 black balls. So N of A is 7. P of A will be 7 by 25. Second part, B, ball drawn is not white. Ball drawn is not white. That means it is either red or black. That means it is red or black. Correct? So that means N of B N of B would be, how many red balls are there? 10 red balls and 7 black balls. So 7 plus 10, which is 17. So P of B will be 17 upon 25. Now C. Ball drawn is either black or white. Black or, no, not black or white. It was black or red, no? Black or red. Either black or red. So there are chances that black or red ball is selected. So yeah, N of C will be again 7 plus 10, which is 17. So P of C will be 17 by 25. And the last part, D, is neither black nor red. Ball drawn is neither black nor red. It means it is white. Correct? It means white. So how many white balls are there? There were 8 white balls. So P of D is equal to 8 by 25. Okay. Very simple. Let's solve the next question. This is the last question for the day. Okay. A box contains 200 pens, out of which 15 are defective. One pen is taken at random from the box. What is the probability that the pen drawn is defective or not defective? Okay, there are two parts of the question. Out of 200 pens, 15 pens are defective and remaining 185 is not defective. Okay, so what will be the answer for the first part? Okay, the sample space is, your sample space is 200 because there are 200 pens. Out of 200 pens, 15 pens are defective. So remaining 185 is not defective. Correct. So sample space is 200. What is the probability that the pen drawn is defective? So let that be my N of A, that the pen is defective. So that would be N of A will be 15, right? So my P of A will be 15 by 200. And the second part, my event B, that the pen is not defective. So my N of B would be 185 because 185 pen is not defective. That means my P of B will be what? 185 by 200. Correct? It's that simple. Okay. You all take down this question, this answer. There is one more way to solve the same question. So I would be explaining one more concept, which is complement. Okay. Okay, first let's take down this, then we will we'll solve the same question in other way. Okay. Write down sample space is equal to 200 because there are 200 pens, right? So that means my N of S is equal to 200. Next line, number of defective pens number of defective pens is equal to 15. Therefore, number of non-defective pens is 200 minus 15, which is 185. Okay, so event A is equal to, this is my first part, selecting a pen which is defective. So my N of A will be 15. P of A is N of A upon sample space N of S, which is 15 upon 200. I can simplify this and write 3 by 440. Second part is event B. Selecting a non-defective pen. That means my N of B will be 185. So P of B would be N of B upon N of S, which is 185 upon 200. Correct? I can simplify this. 37 by 40. Okay. So you have solved both the parts. Okay. Now it's time to learn a new concept, which is complement. Now, first I'll try to explain with the help of a diagram. Okay. Now, this is a sample space. Okay. This is my sample space. Okay. This is the whole sample space. Now, this circle is my event A. Okay. When I am saying this circle is my event A, this part is my event A, that means the remaining part of the sample space, is complement of A, and it is denoted by A dash, or you can also write A bar. It is one and the same thing. Okay, so the components which are not in event A, it is called as which is not there in the event A will be complement of A. So complement of A, how do you write complement of A? You write A dash or A bar, A dash and A bar. Okay, got it? So in the question, in the above question, the sample space had 200 pens. That means there were 200 pens here In the sample space, there were 200 pens, right? The whole sample space contains 200 pens, out of which 15 were defective. That means if I'm saying that my event A 15 is defective, okay, so remaining part is non-defective. So my A complement, my A dash will be 185. Correct? And in the first lecture, I have told you all that probability, when there is 100% probability, it is always 1. Correct? So, when you are in a sample space, okay, in a sample space, always the total is 1. So, event A plus event A dash will be always equal to 1. Or I can say probability of A plus probability of A dash will be equal to 1 always. So, even in this question, okay, now selecting a pen which is defective is event A, and selecting a pen which is non-defective is actually event A dash. It is complement to A. So, for an A, its complement would be A dash. Okay. So, the another way to solve this is, you have to find event A the same way. So, you will find this. Okay. And then instead of writing event B, you can also write it as event A dash. So you can name it as event event A dash, because it is complement to A. So event A dash would be selecting a non-defective pen. So yeah, P of A dash will be 185. Correct? No, sorry. Your P of A dash, okay, I'm not writing 185 because I don't, because then P of A, from this formula, I can say that P of A will always be 1 minus P of A. Okay. What I did is, I have taken P of A this side, then it will become minus A. Right? So, P of A you don't know, but you know P of A dash you don't know, but you know P of A. So, P of A you have already calculated, which is 3 by 40, right? 3 by 40. You calculate this and you will get 37 by 40. Cross multiply. 40 minus 3 divided by 40, which is 37 by 40. This is other way to solve the above question. So you can either solve like this, or you can solve like this. Got it? So this is called as complement of A. So I am repeating again, in a sample space, okay, if A is an event, then the remaining portion is complement of A, which is denoted like this, A dash, or it is also denoted like this, A bar. Okay, so the total, that is the probability of the whole, the total probability is always 1. The total probability of the sample space is always 1. Got it? Okay, that's it for today.